Good morning, friends. Uh, as you know, today is Saturday, and tomorrow there is a test of chapter number 12. So yesterday we have seen a revision of few topics by Jay sir. Okay, and now today we are going to take few important topics which is important for you in maybe unit test or in exam. Okay, let us say first topic we are going to take about Rutherford's atomic model. We know that Rutherford gave information about nucleus, right? So, what is the nucleus? A center part of an atom which consists of entire mass. How much mass? More than 99.99% mass of an atom acquired by that nucleus. And electrons are moving around the nucleus in a circular path, right? But this is the reason why a Rutherford atomic model was failed. As from the mechanics, right? These electrons are moving electrons, and moving electrons emit radiation. If it emits the radiation, because of that reason, its energy decreases continuously. Why? Because the emission of radiation of moving electron, and because of that continuous emission, its energy decreases. As energy decreases, the path of circular path decreases. Means path, it means radius of circular path also decreases, and because of this reason, instead of that circular path, electron follow helical path like this. And after some time, there is a possibility here, there is a possibility when electron collide with nucleus. If electron will collide to the nucleus, then obviously nucleus as well as atom become unstable. Okay, this type of question may be asked as a 1-mark question. And if it is asked what is the failure of the Rutherford's atomic model, at that time you have to explain only this. You have to write in a one sentence that Rutherford's atomic model is failed to explain stability of nucleus as well as atom. Okay, so this is about Rutherford's atomic model, its conclusion and its failure. If it is asked of 2-mark theory, then you have to draw the figure. You have to explain why there is a helical path instead of that circular path, and then send. Okay. Now let us see the solution of this. If Rutherford atomic model is failed, then there is one more model, and it is known as Bohr's atomic model. Bohr's atomic model. Mind well, you have to prepare the entire Bohr's atomic model. Why? Because it consists of first hypothesis that we will see. Second is equation of radius. Third, equation of energy, and this we have already taken as a revision in last Saturday. Okay, so this time we will not take the equation of radius as well as equation of energy here as a revision. You have to follow the previous video, that means of last Saturday's video, as well as you have the class note as well as our textbook. Clear? So first of all, let us see Bohr's atomic model and its hypothesis. Let us take this hypothesis in very short. First hypothesis is about stable orbit. Right? Stable orbit means around the nucleus electrons are moving in stable orbit. Such electrons are known as stable electrons. Why stable electrons? Because this stable electron do not emit radiation. So the problem is solved. The electrons, they are not emit radiation, they are known as stable electrons, and that stable electrons are orbiting in stable orbit in a circular path around the nucleus. Okay? Then, what about its second hypothesis? Second hypothesis is again for a stable orbit, but what it called stable orbit? The stable orbit are the orbit whose orbital angular momentum, that orbital angular momentum is symbolized as L. This orbital angular momentum is known as mvr. This equation we have obtained in 11th standard. And this orbital angular momentum is integral multiple, that is n, integral multiple of h upon 2 pi. What is n? 1, 2, 3, 4 and so on. And n indicates number of orbit. What is h? H is nothing but Planck constant. Okay, so you have to write this two in a proper sentence if it is asked as a 2-mark question. State the hypothesis of Bohr's atomic model. Clear? Just last hypothesis remain. Right? You have to remember it like this way. It is final excited state and it is initial excited state. Final excited state means it is also known as the state having high energy, and initial excited state, this state having low energy. Clear? You have to remember like this way. Suppose this is an electron, right? So it is very nice to see in short from here. When electron transit from high energy level to low energy level, then it emit, what it emit? Photon. Clear? Photon means HF, and this photon having energy equal to that energy difference, means energy of high excited state, energy of low excited state, and its difference, that is minus. Clear? So there is nothing but emission of photon, and this photon having energy which is equivalent to the energy difference between that two levels. In the third hypothesis, there is one more statement which is opposite to that. If electron here it do not emit the radiation, but if it absorb energy, how much energy? That is energy of photon. It is HF is equal to again EI opposite to this minus EF. If it absorbs the energy equivalent to that energy difference, then it may go from low energy level to high energy level. So here low to high, it absorbs the energy and you will get the spectral lines that is known as absorption spectra. And this absorption spectra appear dark, and you can get that dark lines in a white background. And here there is emission of photon, so such spectra is known as emission line spectra, and this emission line spectra is appear bright, and this bright light you can obtain in dark background. So here we have seen almost 4 things. First, Bohr's atomic model, its hypothesis 1, 2 and 3. In third, we have taken 2 more things, that is emission light spectra. Why there is emission light spectra? Means something is emitting. When it is emitting, when electron transit from high energy level to low energy level, how much energy is released? That energy in terms of photon, and this photon having energy equal to that energy difference between the 2 levels, from where it is going to where it is going. Clear? Opposite to that emission line spectra, there is absorption spectra. If electron absorb the energy, then it may go from low energy level to high energy level. At that time, you will get the dark lines. Dark lines, that is known as absorption spectra. So, Bohr's atomic model, its hypothesis, emission spectra and absorption spectra, as well as difference of emission line spectra and absorption line spectra. After few seconds, we will see about spectral series. Lie, ba, pa, break fast. Okay? But before that, have a look for few seconds. Okay? Good. Again, we are talking about Bohr's atomic model, and I have told you earlier there are 2 very nice and the most important theories about that equation of radius. Equation of radius R. What was that equation? Try to recall it. The equation was like this: n square by m h upon 2 pi square multiplied by 4 pi epsilon 0, 4 pi epsilon 0 upon square. Not only that, equation of energy E is equal to minus what was that? M e raised to 4 upon 8 epsilon 0 square n square. Okay, this answer is in joule. But if you want to convert in electron volt, you have to place the value of m, mass of electron, E, charge of electron, epsilon 0, permittivity of free space, and h, Planck constant. In our regular video, we have already obtained its value, and it is minus 13.6 joule is converted into electron volt, and n square as it is, where here n is equal to 1, 2, 3, 4, 5 up to so on. Clear? From here we will have again two definitions, right? If we are taking n is equal to 1, now what will you get? If we are taking n is equal to 1, then put here value 1, you will get first value E1 is equal to minus 13.6 electron volt, right? And this stage is known as ground state of an atom. In a ground state, energy is minus 13.6 electron volt, and this energy is known as what it called binding energy. And what about this negative sign? That also we have seen. The negative sign indicates in this equation that nucleus, around the nucleus electrons are revolving, that electrons are bound towards the nucleus. And if we took n is equal to 1, it means it is innermost orbit. So it will be like this. It is nucleus. This is the electron which is moving around the nucleus, and this electron having energy minus 13.6 electron volt. And because of this minus sign, that electrons are revolving around the nucleus in a circular path. So this energy is known as binding energy of an electron present in a ground state, means n is equal to 1. Clear? If you want to remove this electron, then we have to give, what to give? Plus 13.6 electron volt energy. Because of that minus, it is bound in that stable orbit. But because of this plus, this electron will come out. So this energy is known as, ionization energy. Clear? So from the equation of that E, we have taken n is equal to 1, it is known as ground state, binding energy. If we are giving the same amount of energy but in plus, in the form of kinetic energy, then such energy is known as ionization energy. So what is the definition of ionization energy? Energy required to bring out the electron from innermost orbit to out of atom is known as ionization energy. Clear? Suppose here if we will take n is equal to 2, then you will get E2, and this is known as first excited state. Then put n is equal to 3, n is equal to 4, and so on. Clear? So these two equations individually, 2 marks, 2 marks. And there are the small definitions about ionization energy, about binding energy, ground state, excited state. Clear? Okay. Now let us say that last topic of this Bohr's atomic model, and it is nothing but its limitation. First of all, I am writing each and every limitation in a short. We have already discussed, and from that short word you have to recall the whole statements. Let us check how much you have prepared, how much you have remembered. Okay, let us see. So, first limitation is about odd combination. What was there? Try to recall. Second is about okay. Third one is about fourth. Fourth, yes, four was there. Okay. Now try to recall this. I will say, okay, I will help you. Right? First limitation, that means to calculate the radius as well as energy of an electron revolving around the nucleus, we have used classical physics. The use of classical physics in quantum mechanics, it is an odd combination. Second one, Bohr atomic model gives the frequency of that emitted radiation, but it do not give the information about intensity of emitted radiation. Third one, Bohr atomic model is failed to give. Bohr's atomic model do not give any information about the distribution of electrons in orbit. Clear? And fourth one, from Bohr's atomic model, it is not confirmed that the shape of the orbit, shape of the stable orbit must be circular. It do not give any information about the shape of that orbit. The orbit may be elliptical. Got it? So these are the limitations of Bohr's atomic model. Try to recall for few seconds. Okay? So this is about Bohr's atomic model. Now let us see that spectral series. Okay, first series was Ly, lie, Ba, Pa, break, fast. Alright, lie means Lemon series, and Lemon series is in which region? U R? No, UV region. Means Lemon series is obtained by using ultraviolet light. Okay, this Ba means, okay, Ba means Balmer. It is for visible region, and this Pascal, bracket and Puffin, this all series fall in IR region. means infrared light. By the using of that infrared light, the series are obtained. Okay, the equations are common for all, but with minor change. And you come to know that what is the minor change, right? Each series having the same formula, 1 upon lambda is equal to r 1 upon, here something was there, minus 1 upon n square. As it is first series, the value of n starting from here 1 square, 1, n value starting from 2, 3, 4 and so on. Clear? So, now it is very easy for Balmer second series. So the value 1 upon 2 square minus 1 upon n square to n value starting from 3, 4, 5 and so on. Question by yourself, bracket again by yourself, and Puffer series 1, 2, 3, 4, 5. So again same equation, 1 upon lambda is equal to r 1 upon 1, 2, 3, 4, 5. So it is 1 upon 5 square minus 1 upon n square, n is equal to 6, 7, 8 and so on. What is r? R is known as Rydberg's constant and it having value 1.097 multiplied by 10 is to 7 meter inverse. Clear? So again this is 2 mark question. Write the spectral series only or list the spectral series. Then you have to write 1, 2, 3, 4 and 5. There are few short questions based on this series. That means which of the following series falls in ultraviolet region? If it is ultraviolet, then it is lemon. If it is Balmer series, it is for visible region. And for Paschen, bracket and Puffer, infrared region. Okay, that's all for this revision. Rest of the things you can read easily from our textbook, as well as if you have any doubt, you can check the previous videos. Okay, good luck for your unit test. Be honest and write perfectly.